The second type of tests in two-population testing is a test of variances. So now we may consider two samples which are having variances, sample variances, which are not certain for us whether they could be assumed equal or not. Like in example 1, we had two values which were close enough and we did assume equality, but it could be that we should have tested it first, and based on the output of the test, then we continue and choose appropriate test for the means. So we are basically comparing the spread of the two distributions. Now the test of variances is based on the ratio of those values, and that's where F statistic or F test comes in. So we are basically calculating the ratio, and we want to test how far this ratio is away from 1. So of course 1 would mean perfect equality of the variances, and anywhere on the left or on the right means that there is some uncertainty whether we can consider them equal or not. F-test has two sets of degrees of freedom, n-1 and n-1, meaning the sample size is reduced by 1. First one is respective for numerator, the other one for denominator. And now the decision on the null hypothesis is done as follows. So again, if our test statistic fits now between the left-hand side and right-hand side critical values, then we fail to reject null hypothesis, or in other words, we accept it. And otherwise, if our F statistic is smaller than the left-hand side critical value or bigger than the right-hand side critical value, then we reject null. Why it has to be done in this way? Because F-test or F distribution is such that it is non-negative, it accumulates around 1, and then it goes to infinity on the right-hand side, but on the left it's just 0, so it's not symmetric, and we can't look just at absolute value because F distribution has non-negative values. So we are now talking about this left-hand side, so we are now talking about right-hand side half of alpha and left-hand side half of alpha, and it's always two-sided test in this case. The variances are equal or not. So we have alpha over 2 in here, and then we have alpha over 2 on this side. The test for variances can be extended by the fact that we are given theoretical values for those variances and we compare them with the sample ones. So we extend the test statistic formula by this portion where we now add those theoretical values. And notice that the respective theoretical value for population A is on the other side than the sample, and vice versa for B. The degrees of freedom remain the same in this test, so n-1, n-1, and then the decision is also the same. So once again we have half of the alpha on the left-hand side and half of the on the right-hand side in this non-symmetric F distribution.